Yeah. So what about hypothesis testing? So this is one sample hypothesis testing. Here we will be talking about one sample. So based on one sample, we will make our decision, make our judgment. Hypothesis is nothing but a simple assumption or simple statement that we would like to prove using uh, statistics. Let's say Christine is saying the average age of Eastern Washington University is student is all student like 13,000 student is 24 years. This is the assumption that she made. I'm saying no. The average age of all university student is 23 years. We are debating. She is saying no, I'm correct. Based on 25. My knowledge I'm with university from last many years, 24 years. I'm saying no. Uh, with my statistics knowledge, I believe it is 23. Who is correct? I mean, there are two ways to do that. One is to go to IT person, or those who have the records of the student and they can just pull out the data and can give. We don't have the access of that. We don't, and we can't get that. Let's do, so who is correct? What we will do? So first thing, this is the hypothesis testing process. I'm just going to explain on rough, whiteboard, then we will talk about. So I'm just, so first is a statement. Let's say I'm just going with this, the mean or average is, or mu, mean or population average is also known as mu. I mean, I don't have symbol on my keyboard, so I'm just writing is 24. Okay. So here the first statement is to write the hypothesis. Hypothesis is normally written in H0. Understand, I'm just putting this O, but you can understand this is 0. H0 is, so just a minute. So H0, mu equal to mu 0, and H1 is mu not equal to mu 0. So basically, how do we write here? Just a minute. So H0 mu equal to mu 0. Uh-huh. Yeah. So you simply understand this is called null hypothesis. And there is an alternative hypothesis. So always we write two hypotheses whenever we do, hypothesis testing. Null hypothesis and alternative hypothesis. After that, okay, null hypothesis says uh, mu equal to 24. In what is the meaning of this? Based on sample. So 24, I'm just, or mu 24, or the way, there are different ways to write it. What is the meaning of null hypothesis? Null hypothesis means no. Null means no or means 0. So means you are saying 24, this is population, and based on my assumption, based on my statistics, this is also coming 24, means there is no difference, they are same. means there is a no difference in that. That is the purpose. Null means 0. Therefore, whatever assumption we made, statistically that is correctly, that is coming same. Therefore, no. Alternative is 24 is you made, which is not equal to 24. So alternative is, exactly opposite to null hypothesis. So these are the two statements we make at the beginning. Okay. After this, so first step is to write the hypothesis. First step to null and alternative. Second step is to decide decision rule, or you can decide alpha. That means 5% confidence level, or alpha equal to 5% significance level, or 10%. So what is the difference between confidence and significance level? If you are talking 90% confidence level, that means 10% significance level. If you are talking 95% confidence level, that means 5% significance level. So this is exactly opposite to confidence level. So, out of 100, if you are saying 80% confidence level, means alpha is 20%. Okay. The third step in this, is to let's get the data. How we get? So since we don't have the data with us, we go and we take the sample. We ask randomly, let's say 125 students, and they have given, all 125 students, we have a data now. So 125 students data we have collected from university randomly. Okay, this is the third thing. The fourth thing, do the calculation. The step number 5. Number 5, based on that, make decision. Number 6, reject or accept null hypothesis. And number 7, make your decision. Conclude. So these are the steps in order to perform. Let's say, 125 students, and I do the calculation. I get the numbers, and I can conclude whether this is going to be correct or not correct. So this is the process of, or this is the importance of null hypothesis. One sample. What we are doing, we are just collecting one sample here. Suppose if we do multiple sample or multiple, things, for example, here instead of student's age, I'm talking, average university employee salary in Washington state is 60,000. Randomly collect the sample of like 200 of employees salary, and do it whether this is correct or not. So many cases or many situations you can deal with one sample hypothesis testing. Now I'm going on the slide part. So this is the steps in order to make the hypothesis testing. Get an idea, formulate hypothesis, gather data, find test statistics, make decision, revise your idea. So basically, I just spoke about all those steps on whiteboard, exactly the same. So
we're not seeing your slides, Professor.
Oh, you are not. Oh, just a minute.
Yeah.
Okay, now I hope you can see.
Yes, thank you.
So yeah, get idea, formulate hypothesis, gather data, find test statistics, make decision, revise your idea. So this is the approach in order to do hypothesis testing. Know the steps in testing, define alternative and null hypothesis. So step the hypothesis to be tested. Step 1, specify what level of inconsistency. Like I said, decision rule 5%, 10%. Collect data, make decision, take action. So this is steps. These are the steps in order to make decisions. So null hypothesis, alternative hypothesis. Now here we are going here, type 1 error or type 2 errors are there. So what is the significance of this? I will explain at the end, but understand this matrix. If null hypothesis is true, if null hypothesis is false, reject null hypothesis, fail to reject. Type 1 error, or this is also called alpha error, correct decision. If reject null hypothesis, so I will come later because I don't want to confuse at this point. So let's go into the directly example. So here is the first example. Or let me get the data directly so we can just a minute. I'm just using a data from the previous module. Let again. Okay. So here we are on this, I'm just saying the average GRE score of all Indian students is, so my null hypothesis is, mu equal to,
Another screen.
oh, just share screen. I hope now you can see.
I can, thank you.
Yeah, keep reminding me because I just put my all brain is for explaining. So okay, for example, in this null hypothesis, I say the average age of all, average GRE of all Indian students, 22,000 students, is 320. So an alternative hypothesis says mu is not 320. So this is first step I have decided. Now I would like to check, at what consistency level I'm going to do check this. So I'm just going alpha is 5%. That means confidence interval is 95%. Now, third thing, I'm going to do the calculation. I'm just going to data. I'm going to gather the data which is already here. Now I'm going to do statistics. So here we have three options: one sample Z test, one sample T test, one sample Z, one sample T, one variance, and one proportion. These are the four options that we are going to use in hypothesis. When do we use one sample Z test? When population standard deviation is given. We don't have the population standard deviation. Here when sample is given, so we have sample right here. We can do this either we have in summarized format or we have in this format. So here is the data that we have. So I'm just going to use the GRE score. Okay, perform hypothesis test. I'm going to, what is the hypothesized mean? We are checking with 320. 320. Okay. Options 95% by default it is coming. Remember that, you know, under options, we have to always put the confidence level. So if alpha is 5%, you have to put 90. If alpha is 10%, you have to put 90%. If alpha is 1%, you have to put 99%. Here, alternative hypothesis. So you have to put the alternative hypothesis because it doesn't accept null hypothesis. So you have alternative hypothesis situation here. So the second situation, mean not equal to hypothesized mean. So I just put the first, you know, by default, or the alternative hypothesis, mean is not equal to hypothesized mean. Okay. Now I'm just going to use this. So p-value is 0. Now look into, this is a t-value. This is a p-value. What we can understand, there are two ways to make the decision, whether your hypothesis is accepted or rejected. One is a p-value, one is a critical value. Now look into the critical value situation. So I'm just going to check the t of critical values. So basic statistics, graph, probability distribution, and I'm just going to check t and degree of freedom, which is going to be 449 because we have 500 samples. So 1 minus this shaded area is, and we are just checking 5%. So this is the one. Okay. So what is the value of 0.1 minus 1.96 and 1 point? Where we are getting our t value? 6.98. That means the value is coming in this area. In this area, minus 6.98. Are you getting me? So this red region is called rejection region. So what we are going to reject in this case? We are going to reject null hypothesis. That means null hypothesis. What was our null hypothesis? The mean score or average hypothesized score is 320. And this is saying no. So if null hypothesis is rejected, what is happening? If any value, if suppose calculated t is coming in this area, we can say the null hypothesis is accepted. So I'm just going one more time on the back slide and back, you know. So this is this case. P-value is 0. If this is so, this is critical value rule, which is if your critical value is falling in the red zone, or this, you know, falling above or beyond the critical values, you are going to reject the null hypothesis. P-value, this is another rule that you can apply. If p-value is less than alpha value, p-value is less than alpha value, you are going to reject null hypothesis. You are going to reject null hypothesis. So using critical value, we are also going to reject this. We are also going to reject using p-value. That means alternative hypothesis says it is not 320. Now let me check with another number. So let's say I'm going to use statistics, basic statistics, one sample t-test. Instead of that, what number should I put? Let's say I'm going to put 316. And using 316, what we are getting here. So I'm just going to clear this part. So we get 360, the mean is 316 and mu is not 316 or H1 is not 316. Based on that, again, I'm going to draw the distribution plot. This is our distribution plot. What is the t-value we are getting? 0.93. Where we are getting 0.93? 0.93 would be, this is 0 somewhere here, So our t-value we are getting within confidence level, within this area. So we are saying our null hypothesis is accepted. Null hypothesis is accepted. That means the true ZRE mean of all the students will be with 95% confidence would be 316. And even using the second decision rule, alpha p value is greater than alpha in this case. So we are getting 35% and alpha value is just 5%. In this, using this, we are also going to say this is null hypothesis is accepted. All the students, those who are coming from India, their GRE score will be 316 with 95% confidence, or alpha is 5% level of significance. So this is the way to make the or to do the hypothesis testing. So this is, now you get the value, you get the 2 points. This hypothesis testing can be critical when you increase the, like I did, I just changed the hypothesized mean from 320, I changed the 316. So changing this, the hypothesis is accepted. There could be another possibility. I can make the bigger confidence interval. So there are two ways to do that. Now I come back on my oh, sorry. So this is type 1 error, rejecting the null hypothesis when it is true. This occurs with probability alpha level. Let's say you are doing any example, if that hypothesis is true and by mistake you are putting, instead of 98%, you are putting 97%, or instead of 99, you are putting 98%, significance level. What will happen in that case? It will go in the dark region or red region, means rejection region. So this could be a possibility if hypothesis is correct, or because of alpha level, you decide 98%, 99, or different alpha level, slightly changing, your hypothesis is correct and you are rejecting. This is called type 1 error. Type 2 error we just have seen. Instead of changing the hypothesized mean like 320 to 316, your hypothesis is rejected on 320, and on 316 it is accepted. So this is because of, by mistake, you are assuming the wrong hypothesized mean, and your hypothesis is accepted or you rejected. So based on these two values, the error can be possible in hypothesis testing, which is called type 1 error, which is called type 2 error. So let me go. So basically here you can see two-tail test when you do the equal and unequals. So this is the, I hope you can see my mini tab also. So under basic statistics, when I do here option, if you do this unequal or equal bar, this is two-tail test, means you look on the both side. 0.5%, like you are checking 5%, so 2.5% on the right side, 2.5% on the left side. So this is what we can check here. So, and this is left one side and this is another side. So these are left side and right side. We are going to look into this case also. Hypothesis testing can also be done under assistance. So when you go under assistance, here you have the option under hypothesis testing. Under hypothesis testing, you can look into this compared to, we are not dealing with two sample, we will deal two sample in next class and next 520. Here we are just dealing with one sample T, one sample standard deviation, one sample percent defective, chi-square of it. So we are just looking into these. So data column, I'm just going to check GRE target. Let's say I'm just going to put 317. I'm just doing, I'm just, is here three types of hypotheses are clearly written here. Is the mean GRE score greater than 317? Is mean what we wanted to check. These are the three options. I'm just going, the mean of GRE score differed from 300. So this is not equal to, less than and greater than we will, and this is okay. And here you can see sample size 90%, 95% confidence is 315 to this. Standard deviation target is 317. Look into all this number. So for alpha equal to 5%, the sample size 500, true mean differed from the target by 1.12 in either direction. You would have 60% chance of detecting the difference. It is differed by, so here, and so here this is the test. There's not enough evidence to conclude the mean difference from 370 and 5% level of significance. So here you can see this p-value. What is the p-value we are getting here? 29.6%. So p-value is, the mean GRE score is not significantly different from targeted at 5%. That means hypothesis is also, null hypothesis is also accepted at 5% level of confidence, because p-value is greater than alpha value. So 5% and this is 29%. So does the mean differ from, no, mean of GRE score not significantly different. So this null hypothesis is accepted here. So this is also a way to do that. So this is a rejection region, this is an acceptance region. This is not equal sign. When you are doing equal or unequal, we always use. When you are going to check, reject null hypothesis if the test statistics left tail calculate value. So basically what is happening here, all 95% is this side. Whenever you are checking greater than or less than, which is all coming one side. So for example here 95%, all 5% is on this side. So this is left tail test, because this is left tail. This is right tail, because this is a rejection region on the right side. Type 1 error and type 2 error, we are just I just explained. So here, for example, state the hypothesis. For example, null hypothesis mu is less than or equal to 216 mm. That means mu should be in this. Means this is asking less than or equal to, means this is the rejection region. 5% level of significance. We can check, this 1.645. We can get the critical value. And after that, calculating this, we are getting 2.152. 2.152 will come in this rejection region. So the test statistics fall in the right rejection region. So we reject the null hypothesis and conclude the alternative hypothesis that mu is greater than 216 at 5% level of significance. So if it is coming in rejection region, we are going to conclude that alternative hypothesis is correct. So null hypothesis is less than equal to 216. Alternative is more than 216. And take the action. So, they have to take the action based on the decision. So p-value rule, I already explained what is the p-value. So in this case, the manufacturer decided for two-tailed test, mu equal to 216, mu is not equal to 216. Again, 5% level of significance. But the two-tailed test, so this is, you can see 1.96 and 1 minus 96. See where the calculation is coming, 2.152. It is again going out of the range because minus 1.26 and plus 1.26. And therefore, you can conclude the 5% falls, this falls in the rejection region. Therefore, we can conclude it is not equal to 216. And what is the p-value rule? I already explained. What is the significance? I'm just going to check, show you demonstrate you the p-value. Why we call it less than or more than alpha value? How do we compare with alpha? So when do we use t-test? When we don't know the sigma, population standard deviation, then we use. If we know the population standard deviation, we always use one sample z-test. Look into here, you have to put the sigma value, or you can put the summarized data, but population standard deviation is here is important. So this is another example, mu equal to 142, not 142, 10%, degree of freedom 24. You can see we have calculated, we find the t values using probability distribution graph. So left tail and right tail, degree of freedom, this is the minus 1.7. These are the rejection region. And when you calculate, this is coming minus 1.534 and minus 1.34 would be in this acceptance region. Do not reject null hypothesis. That means since the test statistics lies within the range of chance variation, we cannot reject null hypothesis. P-value is 13% and alpha value is 10%. So, basically, all the questions are related to, this is again based on proportion. A thumb rule is this, always remember n pi must be greater than equal to 10, and this is also greater than n, 1 minus pi is also greater than equal to 10, then only you can go for normal approximation. When the pi value and sample value multiplication is greater than 10 and n 1 minus, then we can use this. So first thing to do this, to check this, and then only you can go for uh, hypothesis testing for proportion. Here proportion mu equal to 0 not. So I'm just going to check, demonstrating one example here. So let's say I have this data. I'm saying basic statistics. I'm going on one sample proportion. I have, which is the only research because this is a proportion thing. I'm just going to use research part, perform hypothesized proportion. Let's say I'm just going to say 57%, all the 22,000 students are having research university based on my this 500 data point at 95% confidence. So null hypothesis is 57% and alternative not 57%. What is the p-value here? P-value is we are getting 68%. And what is the alpha value? Alpha value is 5%. This is greater. So my assumption is correct. My null hypothesis has been accepted that all 22,000 students, those who are applying for university, 57% of them will be having research university. So this is, let's say I'm just going to do 60%. So I'm just changing 60%. In this case also this is accepted because this p-value is 7% and our alpha value is 5%. So again, less than equal to critical value, we can get this critical value easily by so alpha, if you change if your hypothesis is rejected by margin, then you can change the little bit alpha value and maybe that is accepted. This is for variance. So let me check what is the situation in this case. So for variance we are just going to use chi-square test. So I'm going to do statistics, basic statistics, one proportion, one variance. I'm just going to use the variance for the variance of all the university, 22,000 students perform hypothesis. Either I can use the standard deviation or, so let's say I'm just going to write 11 is the value of standard deviation of all 22,000 students based on this sample. What is the, I have all the, 95% confidence. Let's see. P value is 38%. Chi-square, which is, so it is more than 5%. That means, yes, that is correct. Null hypothesis is accepted because P value is higher than significance level. So this is, hypothesis testing. Now, what is the importance of P level? How do we check, if P level is greater than alpha level, then why we accept the null hypothesis? Okay, let me go with this example. So we did this ZRE, T value is 93 and this is 35. So with 316, the P value is 35%. That means what is the importance of this? So just a minute. Stat, basic statistics, probability plot. So first, let me go with t-value with 449 or 499. I think 490 because we have 500 sample, and this is 5%. We were checking with 5%. So minus 1.96 and y. So this is the ideal situation. Our value, calculated value, has to be within this range. 2.5% here, 2.5% here. What when we are calculating, what we are getting, we have given this much area in order to get our calculated value, but technically where our value is coming, probability distribution, and we are getting here, we have 35%. I mean, I'm just, so basically our, we have given this much chance, this much is space to prove our, null hypothesis, but we are getting, our hypothesis accepted within this range. This is much lower confidence. In much lower confidence, this hypothesis is accepted because you can see this. Where's 35%, and the t-value is 0.93. So p-value, this hypothesis is accepted at up to 65% confidence level, where we have 95%. Means 30% less confidence interval, this hypothesis is accepted. So if you have higher value of p as compared to significance level, this is accepted. Null hypothesis is accepted. So here you can see 0.93 and 30. Look into that. 0.93 would be right within this limit. Within this is 0.9355, and 0.93 would be very close to this. Means we have given this much space, but our hypothesis is accepted this within much lesser space. Therefore, this is the significance of p-value is greater than alpha. That means null hypothesis is accepted. This, please keep this, this rule in your mind, because everywhere we will be using this rule. In next class 520, everywhere we will be using this. So this is about chapter number 9. If you have any question, you can please ask me. I tried my best in order to explain you with proper significance, proper, still you feel free to ask me the question. You can, because my purpose is how best I can facilitate you to have better learning, because this course is not easy, to be honest. This course and next 520 course, they are the most difficult course in your entire MBA program. So I can understand, So
It always makes sense when you're talking about it, and then when I start doing the problems, it doesn't make as much sense.
Yeah, actually, this, to be honest, not only you, I teach this online MBA, and only 10% students are able to do, good job, because, statistics, this probability, number crunching, thinking all together, different direction, that's not their cup of tea, they say. Basically marketing, HR, they are excellent into that, but it's altogether different ball game.
Well, I have to use this every day, so it's good to have an understanding of it.
And actually, we can visualize everything using Minitab. We, whatever we are doing, It is not just in year. You can see everything using the Minitab. So just, you know, practically do. For example, I'm just asking you, okay, you can assume that, you know, the salary of university employee in Eastern Washington University, average salary is $30,000 or like $50,000 or $55,000. Okay, you can assume, you can get all the public records on Washington state financial data, that salary randomly you choose like 55, you know, and check on 5%, 10%, whether your assumption is correct or not. It is more than 55% or it is less than 55%. So I just demonstrated you one, you know, option, which is right here. You can see basic, or, you know, or you can do the same thing using public university in Washington state or public university in across United States. You can get the all the data from different state, from different you know, government sites. You just collect and check your assumption is correct or not. So basically, first thing, is it 55,000 equal or not 50? There is a less than 50. Is it less than 55,000 or more than 55,000? So you have, you know, this option. I'm just going. So this is mean is less than hypothesized mean. So this is alternative option. You know, that means your mean means all the you know all the, you know, state university employee mean is less than 55,000. So this is, if you want to prove that, this is alternative hypothesis. If you see the, you know, 55,000, you know, your assumption is lower and the average is much higher or higher than 55,000, you just choose this and see the p-value. Or you have assistant part also in order to do the same thing. Under this, you have hypothesis testing, and, you know, it is properly given in words in order to test that. So yeah, so these are the three cases. Either you have to test equal or not equal, it is greater than or less than, or less than or greater than. So if this is fine,
I'll see if I can use Minitab more than I have been.
okay. So if you don't have any question, I would like to say have a good night. And I don't want to hold up class, but maybe after class ends here, can we go through a couple of more example of proportion? Okay, you can, yeah, Jesse, you can ask me. So okay, let me do this. Just a minute.